Our grandfathers started it. We have only begun to understand it. Our grandchildren will have to live with it.
The greenhouse effect will wreak total havoc on the natural world as you know it.
We can't stop it, and mankind has only itself to blame for the greenhouse effect.
The Journal with Peter Kent.
Good evening. Tonight on The Journal, a full edition devoted to the greenhouse effect, a phenomenon which will eventually cause the greatest global climatic change since prehistoric times. The full effect won't be felt for a century or more, but younger members of our audience may well live to experience the first changes. Our grandchildren almost certainly will. We fully expect a certain amount of skepticism among viewers in this unusually cold winter to the proposition that warmer weather is ahead for Canada and the rest of the world. However, as you'll see, the scientific community is virtually unanimous in the prediction of a warming trend, and that the irreversible warming will create major disruptions of what we've come to consider as normal weather patterns. The only disagreement seems to be in the timing and magnitude of the disruptions caused by the greenhouse effect.
The world's weather patterns are constantly changing. Since the Earth was created 4.5 billion years ago, the weather's regional personalities, the climates, have experienced a kaleidoscope of transformations. For most of the world's existence, normal global climatic conditions have been tropical, interrupted every 200 or 300 million years by ice ages. In human terms, one can relate only to the current temperate break or interglacial period of the ice age that began 3 million years ago. For most of that relatively short period of time, man has been merely a helpless, if fascinated observer of the constantly changing patterns of weather and climate. But in the past century, mankind has set off inadvertently a complex global chain reaction, which threatens to affect irreversibly life on this planet.
Well, putting it quite conservatively, I would say it was the most important of all the environmental questions by a wide margin. It touches life absolutely directly.
What could happen between now and the end of the 21st century will be completely unique. It'll produce a state of the world that hasn't happened for 2 million years.
So we're bringing on ourselves a change of climate that nature herself has not inflicted on the world since long before man appeared in the world.
I think I would be inclined to describe it as potentially cataclysmic. Not a trivial matter and not one to be taken lightly.
The greenhouse effect will wreak total havoc on the natural world as you know it. There will essentially be no Canada or no United States as we know it today.
Just a sample of the broad spectrum of opinion on the changes taking place in our atmosphere and the effect those changes may have on the weather of the future. The greenhouse effect. The world's scientific community is only beginning to come to grips with the global phenomenon analogous to the basic principle of the glass-skinned garden structure. Sunlight passes through the glass shell. The heat created as ultraviolet and visible radiation of the sun warms the interior, kept in by the same walls that allow it to enter. The glass also contains the moisture of the verdant environment through the cycle of evaporation and condensation. Over the centuries, the Earth's atmosphere has acted beneficially as the greenhouse glass does. The amount of heat absorbed from the sun balanced by heat radiated back out into space. But suddenly scientists have become concerned with sharply increasing levels of one of our atmospheric gases, carbon dioxide. Increasing levels which some fear could lead to a disruptive warming trend. The analogy of the heat-trapping skin of the greenhouse with the growing envelope of carbon dioxide around the Earth is a good one. For a more graphic display of the phenomenon, the Journal asked science journalist Bob McDonald to set up this laboratory demonstration.
This is a fairly typical North American landscape, and it's a fairly nice day. The sun is shining down on the land, and it's fairly warm. There's a temperature probe inside here, and it's hooked up to this digital thermometer. Right now, the temperature is about 24 degrees. In fact, it's probably warm enough that you might want to go across the street and have a swim in the pond. There's a common misconception that our atmosphere is heated directly by the sun, but that's not true. What actually happens is that sunlight, which in this case is represented by the studio lights, shines right through the atmosphere and is absorbed by the ground. It's the ground that gets hot and gives off heat in the form of infrared radiation that heats our atmosphere, actually from the bottom up. Well, this town, like a lot of towns in the world, has a problem. Too many cars. Down the street there's a factory. The houses have oil heat. All of them are burning fossil fuels. All of them are adding carbon dioxide to the atmosphere. Carbon dioxide has a different way of reacting to infrared radiation. Right now there's a balance. The amount of radiation that's coming out is the same as the amount of radiation that's going in. But if I put in too much carbon dioxide, in effect, what I'm doing is putting a dome over the entire world. Carbon dioxide absorbs infrared light. It can be heated directly. So what happens is that the radiation that's coming out cannot escape. We haven't changed the amount going in. But the temperature begins to rise because it's being trapped, the greenhouse effect. And we can actually see it here on the thermometer just from these ordinary studio lights. At the same time, as the temperature goes up, water vapor, which is in not only ponds, it's in our lakes, our rivers, our oceans, it begins to evaporate a little faster. As the water vapor gets into the air, it condenses and forms into clouds. We can begin to see the inside of the dome here fogging up. Now, the clouds play a dual role. The first, they help to insulate the Earth, and they contribute to that buildup of heat. But as they get thicker, and because they're white, there comes a point when they'll stop letting the light get through to the ground, and they'll start reflecting light back out into space before it even gets to the surface. So what you have is a rising temperature, but then you come to a new equilibrium. The Earth is a little bit warmer, it's a little bit cloudier, and probably has a lot lousier weather.
The sharp increase in carbon dioxide in the atmosphere can be traced back to the beginning of the Industrial Revolution. The factories and engines, all driven by the burning of fossil fuels. The worthless, and to our forefathers apparently harmless byproduct of combustion, carbon dioxide and other pollutants, was pumped into the atmosphere. Billions of tons of carbon dioxide gradually accumulating as a thermal blanket around the Earth.
And it also happens because we cut down trees, because trees take carbon dioxide in as they breathe. They breathe in carbon dioxide, they take the carbon out of it to make the wood, and they breathe out oxygen, which is very useful for us. So if you destroy forests, you alter the balance towards more carbon dioxide, and if you burn coal, which is just fossilized wood after all, you're putting back carbon dioxide that used to be there a long, long time ago.
The world's forests moderate the growing volume of atmospheric carbon dioxide. Trees need to absorb carbon dioxide for photosynthesis. But the forests of the world are shrinking. Far more trees are being cut than planted. Compounding the tragedy of the commercial forests is the continuing cutting and burning of third world forests to provide farmland for crowded populations. In all, an estimated 1,000 million tons of carbon dioxide are put into the atmosphere every year as the result of deforestation. Still, that's less than a fifth of the carbon dioxide produced by the burning of fossil fuels. The amount burned increases every year. Fossil fuels are the lifeblood of the industrial and developing societies. None of the alternate energy sources being developed are likely to significantly reduce that carbon fuel dependency in the foreseeable future. The scientific community is divided in predictions of just what sort of world the greenhouse effect will create, but they do agree that rather than trying to stop the phenomenon by abandoning fossil fuels, the peoples of the world are going to have to learn to adapt. Stephen Seidel of the United States Environmental Protection Agency, whose report on the greenhouse effect in late 1983 set off a global debate.
Well, it's happening because we're changing the makeup of the atmosphere, and that, in fact, is going to change our climate. Now, our climate changes naturally over time for lots of reasons, some of which we understand, some of which we really don't have a good sense of yet. But what we're doing now is humanity is actually, by its own actions, changing our climate.
Dr. Murray Mitchell, a meteorological scientist with the U.S. Oceanographic and Atmospheric Agency.
Well, it won't happen overnight, It will take quite a while, in fact, for these changes to take place and to be recognized as due to carbon dioxide and not something else.
British science writer Dr. John Gribben, author of Future Weather and the Greenhouse Effect.
We can't stop it happening. We can't fight against it. What we can do is try to understand it, to pick out the changes as they begin to happen, pick out the changes early on, see which way they're going, and then bend with it.
When we return, trying to understand and predict the changes, fathoming the mysteries of the greenhouse effect.